Good day to you all, wherever you are. I think we're live now. Yep, I think we are. Anyway, good day to you all, wherever you are, and welcome to the 9th of the British Interplanetary Society live stream Q&A sessions. Last time on the 7th of October, we were celebrating World Space Week, and more importantly for us, the British Interplanetary Society's 87th anniversary. Yes, we were founded in Liverpool in 1933. Today we are celebrating the successes of a much younger organization, Dawn Aerospace. Now the system seemed to work well for us last time. Let's hope we have a trouble-free session tonight. For those who don't know me, I'm Alistair Scott, a past president of the Society, but now as chair of the events committee, I try to coordinate all our activities. I hope you've all had the chance to watch Jeroen's fascinating talk on the development of the Dawn Aerospace spaceplanes. Judging from the number of questions we've got, it has raised a lot of interest. I'm pleased to have Jeroen with us tonight to answer these questions. And as we have so many of them, I won't waste any more of your time introducing him, but will hand over to him to say a few words about himself and Dawn Aerospace while I search out the questions. Over to you, Jeroen.
Well, thank you so much, Alistair. My name is Jeroen Wink, co-founder of Dawn Aerospace. We're what we call a near space transportation company, working on the delivery of satellites to our spaceplane technology, which the majority of the talk was about. As well as the positioning of satellites in space by means of our disruptive green propulsion technology, and somewhat further in the future also the return of assets from space back to Earth.
Well, thank you very much. And are you ready to answer these questions? With 20 or 25 of them, it's going to take us a little while to get
Then I'm ready if we want to get through them all.
Now, the first one is from Peter Robinson, who he says, please tell us more about the second stage. Will you design and supply it, or is it up to the launch customer to supply it? You say on one slide, zero waste in the environment, but is the second stage expended?
Yeah, so these are like numerous questions. Future customers can rest assured that we will provide it as part of the launch service, and the customer does not need to provide an upper stage themselves. The upper stage will use the same building blocks, so the hydrogen peroxide and jet fuel based propulsion technology, but then smaller and optimized for operations in vacuum. I have to agree with Mr. Robinson, or that it's a good catch that the second stage will indeed be expendable, and in that sense could be considered a waste. But with the statement of zero waste in the environment, we meant waste in the ocean, or the debris in the ocean or on land, and the upper stage will be designed to be demisable, so it is it won't re-enter when it's. Does it re-entry burn? It will just burn up in the atmosphere.
Right, thank you. So the next question is from Luc van der Abelin from the Netherlands, who says, where were the Mark I test flights performed?
On undisclosed location on the North Island in New Zealand.
Right, okay. Well, we'll get through these a bit quicker. Another one from Luc van Abelin, the Netherlands. Is the Mark I and the Mark 0 with NP 120?
I think that Mr. van der Abelen did a thorough research, because I don't even recall when we last used the designation Mark 0. The Mark 0 was in fact a foam replica of the Mark I that we used very early on to gain experience flying, and also to fine-tune and tweak avionics. So no, in fact the Mark 0 was almost like a pilot, like a trainer vehicle, but then for remote operations. The Mark 1 and the MP22 that he's referring to, the MP22 is one of the larger bipropellant rocket engines we made, and that is powering the Mark 1 UAV.
Right, thank you. So another one from Luc van den Abelin. I hope I'm pronouncing your
Very
name
thorough
correct.
indeed.
I'll get it right on the last question. Right, does Mark II use jet engines for takeoff? Designation fuel thrust?
Yeah, well, during initial test flights, it will use jet engines. For the once we progress further in the test flight program and becomes a full operational capability, it won't have jet engines. It will have a rocket engine. But the jet engines we use for the first test flights, they use jet fuel, and I think that's about as detailed as I'm willing to disclose. But they're off the jet engines we didn't develop ourselves. They're off the shelf hardware that we procured.
Right. Okay, thank you. Another one from Luke. He's certainly got them listed here. At what altitude does the Mark II rocket engine, NP 120 ? Take over? How long does it burn for? And what's the thrust?
Yeah, so the Mark II, first of all, doesn't have the MP 120 rocket engine. It has a much larger and much more efficient, higher performance rocket engine. And as I said in the previous question, the jet engines are only there during the first part of the flight test program to say have a lower risk or lower maintenance propulsion system to get initial flight testing done in the low energy part of the flight envelope. So there is not one designated altitude where we switch from jet to rocket. That is dependent on which test, and in the nominal operations, it's only a rocket. So there is then no switching at all.
Okay, thank you. Another one from Luke. This is going to go on all night. So he says the speed. What is the speed at re-entry for Mark II and III?
For Mark II, this is around 3 times the speed of sound. For Mark III, this will be slightly higher, or not slightly, like significantly higher, more towards Mach 5. Right.
Okay, and again from Luke, what material or type of TPS is used in Mark II and Mark III?
So the Mark II is a full carbon composite airframe. It's not, say, the standard carbon epoxy that you would find, I don't know, some high-end cars, or I don't know. I used to play field hockey, and then the richest kids, they had a carbon hockey stick. Like, it's a bit fancier resins in there than that are heat resistant. But the exact type I will not disclose. That's for the Mark II. For the Mark III, this will be largely the same, but probably at some locations reinforced by some super alloys, like metal super alloys at places where the heat flux is too high for the composites.
Right, I'm told I'm not actually answering the top questions. I better go right back and have a look and see which ones. Oh yeah, well, I see we've missed one, we've missed two. Right, I will go back up to the top, because we've got one here from Les Shoulder, which says, unfortunately, we've got another one that shot to the top as well. Let me do the Les Shoulder one first.
Very dynamic.
When or if unmanned air vehicles and passenger flights are allowed to mix in the same airspace, a near miss or potential collision, if not worse, is inevitable. And despite the everyday use of sat-navs and satellite TV, the general opinion of what space can do for you is not very high. And any bad publicity could halt a potentially vital resource. So do you think your type of activity could survive the general public's clamor to shut it down?
Well, the answer is to the last part is definitely yes, and that is largely because I don't agree with the premise of the first part that a crash is unavoidable. Like the fact that it is an aircraft and we will operate very frequently, like orders of magnitude higher frequency than typical launchers, doesn't mean that we swarm the sky with space planes within a few years. So yeah, to give an idea, there are around 100 launches globally right now per year, compared to, well, 100,000s, if not millions of flight movements each year. So when we push the bar, or raise the bar, I guess is better English, when it comes to space flight with an order of magnitude, or 2 orders of magnitude, or even 3 orders of magnitude, it's still very small compared to aviation. And there are still many places where we can do these type of operations without being at risk of collision, as long as we follow the right protocol in collaboration with the regulators, the Civil Aviation Authority in New Zealand, and their equivalents in other countries.
Right. Okay. Right. Well, I think I've got the right question now. Another one shot to the top, and another one from Luke, actually. And he says the payload bay door is not visible on the Mark II delivery. Mark II vehicle, why? Or why not, I should say.
Well, I guess it has to do with the paint job, that the door is on top where the vehicle is painted black. So I guess it's not, from a distance, not that well visible, but rest assured there is a door there. And if we would zoom in very closely to the pictures, to the photographs, you can definitely see the door. But it's, yeah, a black door in a black, how do you say, frame. So I guess that's why it's a bit hard to see.
Okay, but it is there. Good, right, we've got the answer to that one. The next question is from Adam Page. Says, what are your views on open... Oh, it's just shifted. Hang on. I've just lost that. There it is. What are your views on open source, and how have you found navigating Itar in that regard? Is New Zealand the only place where building this is possible?
So these are 3 questions, and I think I will answer them in the reverse order. So is New Zealand the only place where building this is possible? There I would say the answer is no, especially not the building part. And in fact, the building, the development of the Mark II spaceplane was a more or less 50-50 split, because between the guys here in the Netherlands and my colleagues in New Zealand. I would say that New Zealand is maybe not the only, but definitely one of the very few places on Earth where you can fly such a vehicle at a cost-effective manner, because the regulators in New Zealand are very forward-thinking, very proactive. So they have already foreseen in their regulations the specific rule sets for unmanned vehicles, and that is something that is lacking, for example, in Europe. So in Europe, these type of flight tests would not be possible, at least not the way we're going about it. So that's the last of 3. The second one, I believe, was about navigating Itar. Yeah, right now, like Itar is can of course be tricky. Right now, the IP is developed in Europe and in New Zealand, so it doesn't directly apply to us. And the activities we've done so far are not Itar controlled. But once we move further into the future and we want to launch orbital payloads, that definitely becomes an issue. And I believe the first part was our opinion about open source. I can't say we really have an opinion about it. Like we like it. Personally speaking, I like it, but as a company, we don't really like move in that space. So right. I cannot comment on the first part.
Okay, well, we all know the problems there. I used to build airplanes. Right. This another one from Luke has written to the top here, and it says, what rocket jet engine will be used on Mark III, and what are the specifications?
So it is a rocket engine. It will use it's basically a much higher thrust and slightly higher pressure version of the engine we developed now for the Mark II. So it will be powered by propelled by hydrogen peroxide as oxidizer and jet fuel as a fuel. And that's, I think, all I am willing to say right now about the Mark III. Or the engine, at least. I'm not sure what else Luke has up his sleeve.
I expect he'd like to come and talk to you separately after this.
Yeah, well, his name sounds very Dutch, so he's probably not living too far from here. So
yeah, just down the road by the sound of it. I expect he'll message us in a moment, and we'll find out exactly what he's been doing all these years. Right, let's move to the next question. And I'm just trying to see. Yeah, this is from Mike Lawford. And he says, I would be interested to hear what your, oh, here it is. They keep moving.
Yeah.
What you're doing to make your team more diverse from a gender perspective, please. As per your comment in the presentation that you were trying to do something about it.
Yeah, so we noticed, so we started the company back in 2000, well, the earliest start back in late 2016 with 4 young guys. And when we started growing, they were mostly new members of the team were mainly young guy engineers who were, say, quite similar in attitude and phase of life as we were. And we realized that is like we need to broaden our view, and even if people don't, for example, when we have a vacancy available online, and that we should reach out to people that we think are a match, and not wait until these people come to us, because that has been our approach in the past, and that has led to a very non-diverse group of applicants, at least when it comes to genders. So that's one concrete thing, is that we will be more proactive about this than we were in the past.
Right. It sounds as if you're going to have to form a proper human resources department to go and do it.
I think that is part of every company when it grows. The question is when. So it's a matter of when, not if.
Well, they may solve all your problems, so I'll let you get on with that one. Now, come to the top of this one is one from Paul McDermott, who says, what format is the second stage payload, in bay or the nose?
It's in a bay, so it's not in the nose cone. It's a bit further aft it will be further aft in the fuselage.
Right over the center of gravity, no doubt.
I will not disclose too much details.
It's the problems we had with HOTOL. If I go back in history, I wonder if we've got any HOTOL people on the talk tonight, because I had to write all the press releases way back in the 80s.
Yeah.
Right, let's go. Another one from Luke here, who says the Netherlands it keeps, new questions keeps coming up and I can't get the right one. We tell you what, I better finish off the one from Luke first. He says, does the Mark III Kickstage perform a re-entry burn?
Yeah, so the Mark III is a 2-stage to orbit vehicle. So the second stage that we talked about in one of the first questions is the same as the Kickstage. So yes, it performs a re-entry maneuver after the payload is delivered, and during that re-entry maneuver, it will also demise in the atmosphere, like upon re-entry.
Okay. Now, I've got one here from Gerard van der Haar, and he says, Jeroen has the $10 million deal, I must put dollars in, mentioned in the press. Has it been realized yet, and with whom?
I think when he says the media, he probably refers to the Space News article from this beginning of this year. And as we all know, soon after, the world changed a little bit. So all I can say is things are postponed, but still ongoing. And because they're ongoing, I cannot disclose any details.
Right. Okay. The next one here is from Supernova Labs. And it says, what is the split of operations between New Zealand and the Netherlands?
First of all, it's a very dynamic one that, again, with COVID also changed a bit. But it's roughly a 50-50 split. On both sides, design is happening. On both sides, manufacturing is happening. On both sides, testing is happening. And it really depends what is opportune to do at what location, at what time. Safe to say that all flight test activities are performed in New Zealand, and that also means that for the space planes, at least, the final assembly takes place there, because we assemble them as close to the flight test facilities as possible. But for all the rest, as said, that is pretty much a 50-50 split, and wherever the vacuum chamber is free, that is where the next space thruster will be seeing its acceptance testing. It's something that's quite dynamic. We started the company, as I said earlier, in the end of 2016. But by now, 3 of the 5 founders and in the management team are in Christchurch, and myself and my other colleague are permanently located in the Netherlands. So yeah, from strategy to day-to-day operations to construction to testing, it's a 50-50 split that is quite dynamic.
But I expect you'll go out there for all the celebrations.
Like COVID allowing, I would say.
Yes, that's the problem we all face.
If it wasn't for COVID, I would be probably over there right now. The terrible Dutch weather this time of year is one of the reasons, but
yeah. Well, I did 7 launches on the PR side, 7 launches from Kourou and 6 from Canaveral.
Oh yeah.
The best whiskey and wine was in Kourou. Right. Let's get on with the next one. Oh, it's shifted again. I thought I had it. Yeah, that's the next one is, if the landing, this is one from, it just says comment, don't know who this is from. If the landing is by gliding after re-entry, how can you ensure safe access to an airport used by conventional aircraft? There would appear to be no alternate options available. Should there be a problem with the runway, for example?
So there are a few things to consider here. One is that our vehicle has a much higher lift over drag ratio than something like the space shuttle has. So even when gliding down, there is a lot more energy available to maneuver and change course. Then there is also some excess propellant left to have some additional energy for maneuvering if so required. And the vehicle is equipped with ADS-B and other required systems to be able to detect other users of the airspace, also to make itself known to those other users. So it has seen and be seen capabilities and quite a significant collision avoidance capability.
Right. Well, thank you. Yes. The number of times I've had to avoid birds is the problem. Now this one's shot to the top again. Here's another one from Mike Lawford. Who do you anticipate will be your main competitors, and why will you be better than them? I.e., is it the terms of cost over availability of local launch locations worldwide, or lead time to launch?
So basically, like our initial target market is the great many amounts of satellite constellations in low Earth orbit and small constellations consisting of small satellites. So that gives a vast range of competitors as well. as you know, a small satellite can be launched with a dedicated small launcher, which there are more and more of these days. But it can also be a piggyback customer on a large launch vehicle like the Vega from Kourou. So in that sense, all launches are competition. The main differentiator here is, in fact, not one element, but it's the combination of the very high flight cadence we can achieve, coupled with the very high rate of responsiveness. So not only can we fly very often, but we can do that in a very responsive manner, so with a very short lead time. And this can all be achieved while having an extremely low cost point, because our recurring costs are orders of magnitude lower than for any expendable launcher. So it's really a new class of vehicles. It's really a paradigm shift. This is not another rocket. It's bringing the operational model of aviation, and with that, largely the cost effectiveness of it, to the domain of spaceflight.
Well, I think you've answered that one. Okay, I've got another one from Les Shoulder here. Just try and get it into the middle of the picture. Les says, you cannot carry enough propellant to travel far. It's disappeared again. I don't know why these keep moving.
Hey.
No, there it is. It's dropped down the page, but let's ask it anyhow. So you cannot carry enough propellant to travel far from launch before going supersonic. We saw how much opposition there was to Concorde. How confident are you that you can control the negative impact of sonic booms? This also applies to the problem with crowded areas, such as North America and Europe, as previously identified. Would it require launches only over oceans? And could you be far enough from land not to impact on coastal areas?
So there are a few elements to this. One important factor to consider is that our ascent trajectory is quite steep, and at the same time, for a rocket, not very high thrust to weight initially. So long story short, we break the speed of sound at quite high altitudes only. That doesn't rule out that sonic booms may be a limitation when launching over land, and that, you know, while in theory almost any airport would suffice for us to launch, that in reality, because of noise and perhaps sonic boom restrictions, only a subset of airfields are suitable for our operations. But this is not considered a problem to us. So to give an idea, there are around 20 spaceports worldwide, whereas there are at least 20,000 airports worldwide. So even if only a small subset of those 20,000 airports have a suitable location when it comes to the trajectories we want to fly, as well as the limitations with crowd and noise that were mentioned before, then we're still talking orders of magnitude more possible locations than when you look to a conventional launcher. Plus, it is using existing infrastructure, which is something that for most new rockets, new launch pads have to be built as well.
Yes, well, thank you. Right, now I've got one here from Jack Osborne, and he's saying, hi, I'm an A-level student doing EPQ, which is a research project into space planes, and I'd be interested to know what specific functions you believe space planes are likely to have in the future, and why you believe they are better than the reusable rocket alternative.
So the role we see, we don't see any reason why in the future any launch will happen with different technology than the space plane. And the main competitive edge we see over expendable rockets is quite clear. Expendable rockets, I think, are on their way out. It's just a matter of how fast. When it comes to reusable rockets, the main advantage remains in the fact that this is when the vehicle comes back, but actually also on its way up, has collision avoidance capability, in a much higher, much more collision avoidance capability than an expendable rocket like the Falcon 9 has. And that's what makes it possible that we can, in the future, integrate with air traffic. And that just makes the possible launch cadence and the responsiveness of those launches much higher than when it is a vertical takeoff and landing vehicle that has very little maneuvering capability outside of its nominal trajectory.
Okay, thank you. Right, I've got one here from Stina Ojala, and it says, this is Russ, it's Russ again. Right, this is Russ via Stina. Has there been any involvement with Skylon project with Alan Bond, since they were using an air breathing concept, which I'm sure you're familiar with? Is the concept a viable proposition to use in the future as spaceplane? Thanks, Russ.
I believe these are 3 questions. So yes, we are familiar with Skylon and the Sabre combined cycle engine. We are not affiliated in any way. I do see it, especially the air breathing rocket engine, the combined cycle engine that they are developing as when it works and is demonstrated, a game changer, and the ideal form of propulsion for our, let's call them Mark IV or Mark V vehicle, whenever reaction engines is ready to sell that technology. So yes, we very much look forward to that technology working. But right now, we cannot access that technology, so we're sticking to our in-house developed rocket engines.
Actually, that's where I was going to ask the question. Does that include a second stage? Are you developing a second stage of your own?
Yes, we do.
Yeah, okay. Right, we've got one here from Alex Wood, another BIS member, and he says, how dependent is your business model on the predicted boom in commercial satellites that you mentioned in your slides? And how confident are you that the boom will be as steep as predicted?
I am not confident that the boom will be as steep as predicted. Very little things in life are panning out as, you know, the optimistic predictions are at the start. We're not very dependable on it because space, using satellites for services on the ground, be it observation, be it communication, etc., etc. This is proven. This has been a market for a great many decades now already. And so there is a demand for launch, and there will be a demand for launch, even if the boom won't be as big as some people predict it to be. And this is just the superior technology to cater that already existing demand. The fact that it is a boom market helps a lot in getting people enthusiastic about our development and to get them to support us financially or otherwise. But we're not dependent on that boom at all.
Okay, thank you. All sorts of sub conversations going on here. This is very, very confusing. Right, we've got one here from Fabrizio Bernardini, another fellow of the Society. Are you ready to cope with the loss of a vehicle and therefore recover quickly from that, not to slow too much your development?
Well, there the answer is yes. So we have in-house capability to build pretty much the whole vehicle. Or well, not pretty much, the whole vehicle, period. We develop in-house. There are, of course, some components we buy off the shelf, but those are, well, off-the-shelf components, so lead times are quite overseeable. We keep stock of most of the long lead time parts, and we have spare parts of tanks, pieces of airframe. We have the full production capability in-house, so recovering from a damage or a loss of vehicle can be done in a rather short time frame. Dependent, of course, what the cause of this loss is. If it is something, a fundamental design flaw, then the recovery might be a bit longer. But if it's faulty operations, that can be recovered from quite quickly.
Yes, fascinating. We used to have to batch produce 10 at a time when I was building business jets. Right, we've got another one from Les Shoulder here. And he says, judging by the drawings in your presentation, the Mark III next generation spaceplane is about the size of a medium class business jet. But because of its necessary narrow wingspan for its operational flight plan, it would probably need at least a small regional airport to have the required runway length. Given the restraints that the authorities place on any authorized use, can you really be optimistic as to the success of your project? And what are the possible problems you face?
Oh, I mean, the possible project we face, there are many, and I think most of the people here are familiar with aerospace in general. So the problems are plenty. But to the topics that he referred to in the earlier parts of his question, I think it's quite related to one of his earlier questions about the noise and the sonic booms. Yes, there are certain requirements we have on the airport. So a grass strip or a dirt strip will not do. It needs to be paved and it needs to be of considerable length. But again, when we look at the comparison, 20 spaceports on one hand, 20,000 airports on the other hand, we can cross off quite some airports for their unsuitability and still remain with a very substantial amount of airports that are suitable from both an infrastructure and a location point of view. So yes, I think one of the parts is, can you be confident or can you be optimistic? And yes, we are optimistic. So
yeah, you'll have to have a spaceport of your own. Right, we've got one here from Rick Newlands, and Rick is asking, are you having problems with CG and CP movement as HOTOL did?
Yeah, this goes into quite so problems is of course also a rather generic statement. So yes, this is not a trivial thing, but I won't go into too much detail about the specific aerodynamic design.
Right, okay. Yes, I remember the problems. That's why we got a lovely big model in our reception area in the BIS. Because, I stole it. Right. How many employees?
Maybe I can still actually comment a little bit on that. We have a bit more flexibility than HOTOL and Skylon had, as we are not attempting single stage to orbit. So the flight envelope, at least in terms of Mach number that we operate, that our space plane has to operate in, is much smaller compared to a single stage to orbit vehicle. Plus, we have some more freedom in where we put the second stage and payload stack. So there's still challenges there, but the problem is much less. It's less challenging than with HOTOL and Skylon, and we have also more options to solve it. Not saying it's trivial, but it's definitely less challenging than the more ambitious British projects that were mentioned.
Yes, well, we'll see. Now, I've got one here. How many employees have you now in New Zealand and in Delft?
So we're with 35 at the moment, and not including interns. And of those 35, I believe at this time we have 18 here in the Netherlands and the rest in New Zealand. But there's also a few people that are employed in the Netherlands who went to New Zealand for engine testing, and then it was hard to get a flight back when COVID hit, so they elongated their stay a bit. So as said, it's dynamic. Who is where? So that answer will change week by week, but roughly 50-50. And 35 in total. I hope that answers the question sufficiently.
Yeah, that was another question from Gerard van der Haar. Okay, I've got one here. I'm just trying to think if this is the next one. Yes. Have you demonstrated, this is actually, it doesn't say who that's from. Could it be? I'm looking to see what the color coding is.
Oh, yeah.
And yeah, have you demonstrated your sense and avoid technologies for airspace integration? I assume this is sensors.
Yes, so we fly the hardware and software suite on a smaller vehicle now. Practically every week we have a flight test in restricted airspace to keep on to demonstrate it and to demonstrate the full set. And we're working with the Civil Aviation Authority now to get that going on the Mark II as well. So we're in the process of it. I say we just to be clear, we have not obtained the certification that we requested yet. It's a work in progress. So in that sense, it's not fully demonstrated yet, but we're taking little steps every week with this.
Yes, thank you. Right, I've got another one from Les Shoulder, which I think we may have answered part of it, but let's try it again. He's actually saying, mixing civil aviation movements alongside your own unmanned air vehicles would, I believe, be a lot further away than the next 5 to 10 years in such crowded airspace as North America and Europe. Could your project succeed if it was only able to operate in underpopulated areas, as you may be required to build your own infrastructure?
Well, the project could definitely succeed if we only operate in underpopulated or less populated areas. And the fact that an area is relatively sparsely populated does not automatically mean that there is zero infrastructure. In many countries like the US, but also Australia, New Zealand, and even some parts of Europe, it's quite the opposite. Also, the sparsely populated areas do have basic aircraft infrastructure, as well as roads connecting to it and an industrial base supplying it. So yes, the project can very well succeed if we do not fly from Heathrow or from Amsterdam Schiphol, but from some more remote locations.
Yes, know a few of those. I used to fly business jets around Africa into some of the roughest strips I've ever known, but they were near the equator, so it might be useful.
For particular launches, luckily for us, the majority of the growing market in low Earth orbit is in rather high inclination orbits, so we might not have to resort to the equatorial Africa for.
Yeah, okay. Until someone wants to go into your stationary, then you might have to.
Maybe for the Mark IV, we will.
Mark 4 or 5, yes.
Because we are not ambitious enough yet.
It'll come. Right, now I've got a question. Yes, they've all moved around again. I think we've got one here. Oh, here's one that's shot to the top from Fabrizio again. Assuming you prefer to hire younger people, what kind of skills are you looking for, and where can a young engineer apply or propose a candidature?
The last part is via our website. It has a careers button, and there is a list of both the open vacancies, which I believe right now there are two positions published in the field of business development. And then there is the internship program, which is right now purely engineering focused. But in fact, we're looking for people with, say, expertise in all disciplines. So most of the engineering disciplines, as well as anything required to run a business. Because we're not only the focus of the talk today was the space plane, but of course a large part of our business as well is focused on the satellite thrusters, which are now some of them at least are qualified products. There is one of them in space, launched last September. 2 other satellites, one carrying 1 thruster, another one carrying 6 thrusters, will be launched coming December. And a few of those customers are also placing recurring orders. So there is the much more of a business side as well. So sales, operations, quality assurance, legal, everything. It's a real business, real company. It's not only an R&D project.
Yeah, and you have a complete international mix of people as well. I know
Yeah,
Fabrizio would like to pass the CVs over of some of his Italian colleagues.
yeah, well, sure. The via the careers. So I mentioned that on the careers, if you click on the careers button, there is a list of vacancies, but there is also a button for say general applications. If the people see that they still want to reach out to us, but are not a match for any of the open positions that are published there. We do read them. There are a lot, so sometimes it takes a while before we get to respond. Because yeah, we get dozens of them every week. But yeah, that's the way to reach out. And even if it takes a while before we respond, rest assured we do read them and we will get to you.
Well, I was fascinated here. You mentioned the September launch of one of your thrusters. I believe that was on a D-orbit iron.
That is correct.
Yeah, well, they're speaking with us next month. So I've got Chris Brunskill talking about what D-orbit can do. So that'll be interesting.
I ought to be sure to tune into that one.
Yeah, you might be able to ask some very awkward questions.
I will refrain. I promise them I will refrain from doing so.
Well, why? Right. So I've got one here. It says, this is from Paul McDermott again. And he says, are there any current plans, loose or not, to up the payload capacity beyond the 100 kilograms?
Yes. These plans are there, and how loose or how firm they are, I cannot comment on. But yes, the plans are there.
Right. Okay. So we'll be going up to 6 tons next.
Why not? Huh?
Ambitious. Right. I've got another question here that says, who are your main competitors?
Yeah, I believe we already came across that same question before. So basically, every launch vehicle in that sense is a competitor. But as said, the very low recurring cost coupled with the high launch cadence and the low or the short lead times really make this a class apart. So I believe on the long term, the only serious competition we will face are these super heavy launch vehicles like the ones that SpaceX and Blue Origin are developing, because there is the possibility that due to their sheer scale, even though the launch cadence will be much lower, they can offer prices that are quite competing. Anything in between, I don't see as competition on the long run.
Okay. I think I've got one shot to the top again here. And it's from Supernova Labs. And it asks the question, how have you found pitching this as a concept for funding? You've already clearly been very successful in that regard, but knowing the troubles of pitching commercial space planes, what is the moment you finally cracked it? Or what was the moment?
I think what was for us a very important moment is when we started flying the Mark 1 with its rocket engine. And how we went about that was that, well, we started the company coming right out of university, so not like our pockets might have been deep, but they were very empty by the time we were done studying. So yes, we found it challenging to raise money at that point, but we decided, well, then let's just see what is the let's say lowest cost thing we can do to still get our point across, and that's what we set out to do with the Mark 1. So our points of being rapidly reusable, being an aircraft, and being able to fly autonomously. That is what we wanted to demonstrate, and we managed to do that with quite a low out-of-pocket expense. So by investing our evenings and weekends and pitching together a little bit of savings, and we got a little bit of sponsoring from university left and right to buy some components, we were able to develop a 3D printed liquid rocket engine, to develop the avionics for the aircraft, to buy that airframe and to adjust it where needed and to get it flying. And yeah, that was a very, I guess, appealing thing for investors, that it was not PowerPoint rocket number 105, but that it was something that was actually, despite being small scale and low performance, something that was built and flying already. And I think what also helped a lot is that when we were developing the engine for that vehicle, we used that same technology as a basis for the smaller satellite thrusters, and that around the same time, so the end of 2018, the Dutch satellite company Hyber placed a lot of faith in us and selecting us as the propulsion supplier for their future satellites. So then we not only had a demonstration, but we also had a customer. And I think that that combination of having, actually making revenue already and having the flight demonstrations is what helped a lot in future fundraising.
Yes, I think some of the comments we've got coming up here that hardware really does sell something is true. If you see something that's working, then it's worth investing in.
Yeah, and we of course, before starting the company, we worked together already for a long time in the student society building rockets, and there it was also, let's say, the university there is very generous in providing workshop and machines to work with, but it didn't provide funding. So also the student society we had to look for sponsoring, we had to look for funding, but it also made us very creative in building something when your procurement budget is very small. So that left us already with a great skill set as well as a tool set that we could leverage to build this vehicle.
Yeah, great. Well done. Right, we've got one from Alex Wood here. He says, what has been your most difficult challenge so far, either in technology or business development?
The most difficult. There are plenty of challenges, so picking the most difficult one is a bit hard. I would say the most challenging thing is now that we so earlier I discussed having both the spaceplane development as well as selling products already being very helpful in raising funding, which I believe is true. But at the same time, this also means that there are two very different sides to the company, and balancing that. So on one hand, the very tough R&D and long-term project, with on the other hand the day-to-day operations and dealing with customers, but also with all the other stakeholders that are involved in a launch campaign. Balancing the time of myself and the rest of the company between those, I would say, is the biggest ongoing challenge. Also the most interesting one.
Yes, once you've solved it. Right. Well, I think we've had this question before, but let's ask it again. This is from Paul McDermott, and he says, is the second stage a nose module or some other payload format? I think we've more or less had that one, but I'll ask it again.
Yeah. Well, it won't be in the nose cone. It will be further aft.
And it will be released from a payload bay of some sort.
Exactly.
Yeah. Okay, I hope that answers your question, Paul. Right. Do you have any difficulty? This is, again, from an unknown. Do you have any difficulty getting launch slots?
No, because we don't operate as a launch vehicle. We operate as a unmanned aerial vehicle. And there the jurisdiction is very different. I would say it's even more the regulations surrounding it are even more strict. However, once those are overcome, there are many more places to fly. Again, the 20,000 airports versus 20 spaceports type of situation.
Right, so you don't have to book a slot years in advance. Great. Okay.
For our flight test program, that is. I must say that our customers who are buying the satellite thrusters, what I hear from them is that it is very challenging to launch, and that these things need to be booked very much in advance, and then still they are delayed massively, very often. So yeah, I think for most launches and satellites, this is a challenge, and that is one of the reasons we developed the spaceplane to begin with.
Okay, so you're going to show us how it's done or should be done. Right, we've got one here from Steve Salmon, another fellow. If your vehicles are remotely piloted, how big a threat is cybersecurity as regards the prevention of a takeoff of your vehicle by potential cyber terrorists?
Yeah, so to clarify, the vehicle operates autonomously, but there is always the override possibility for remote control. And those channels are highly encrypted. And that's the main line of defense.
Right, so you won't be interfering with air traffic in Heathrow Airport just yet.
No, but this is similar to working with aviation authorities when it comes to flight test and airworthiness. We, of course, also have to comply to the, let's say, national equivalents of the ITU when it comes to radio licenses. So we have licenses for the frequencies we operate in. So that's all well coordinated. So no interference.
Okay. Now we've got one here from another one from Gerard van der Haar, and he says, "Can we visit you in your Delft office?" Gerard and Luke from Holland.
In principle, yes, but I think Gerard will also know that our Prime Minister gave us a very strict speech the other week, asking everyone to stay at home as much as possible. So as soon as our Prime Minister allows it, everyone is welcome again. But right now, yeah, more than half of the employees are told to work at home, and who doesn't really need to be in the workshop and who can work from home is asked to work from home. So, well, that regime is in place. Having visitors for a tour is not really appropriate.
Yes, we've got the same problem at Stevenage. We were trying to take our old pensioners on a site tour, and they won't let us go until next year.
Yeah, I believe at the moment, or not I believe, I know that at the moment in the New Zealand side, things are a bit more straightforward. It's a bit more relaxed at this time. So for whoever is tuning in from the other side of the globe, you might have better luck there, and you can reach out via the channels on our website.
Yes. So if you can get a trip out to New Zealand, you might get a better chance of meeting up with you, or at least with your team.
Yeah, with my team.
Right. Okay. We've got another one here that says, "How do you iterate your design so quickly?"
I don't know if it's so quickly, but the key is to invest sufficient amount in tooling and in like production capability, so you can iterate quickly. So there are a number of things that, like for practically every element in the vehicle, there needs to be a decision: are we going to make this or are we going to buy this? And we are very careful to only buy things that can be bought on short notice, and that everything that is critical or core IP and would be developed bespoke for us, and hence would come with a long lead time per iteration, that is done in-house, and that we're capable of doing that in-house. And that's key to have a fast iterative cycle.
Okay. Right, the next one then. "Should other universities adopt the Dream Hall model? I have visited it and have been impressed by it."
Well, having practically lived there for some years, I say yes. For people who are not familiar with what is meant, it's a facility that the Delft University of Technology, I think, used to have, because I believe they actually recently closed it or revamped it. But it used to be the case that it was a big building, a big workshop where there are a number of machines available for communal use. So a few lathes, a mill, bench work equipment, etc. And then, so that was in the central hall, and then surrounding it are a number of small workshops, and each team has one of these small workshops where they can develop their vehicles. So in my time, there was like a solar-powered car, and there was a hydrogen-powered car, and I don't know, I believe a motorcycle fueled by bioethanol or something like this, like a lot of vehicles being designed, built and tested by student teams.
Right. Okay.
And with little university or faculty interference. So it was really carried by the students themselves, which, yeah, I enjoyed that environment a lot. So I can only endorse other universities to adopt the same.
Yes, well, I was at Bristol University and we made pedal cars in our workshops.
I see.
Far more. Well, Concorde was being built along the road, so we didn't have the sort of competition. Right, we've got another one here from Paul McDermott. And he says, how does the release work from a payload bay in upper atmosphere, admittedly extreme, at supersonic speeds?
Yeah, so just to clarify, the Mark II spaceplane, which is a scale model of the first stage of the Mark III, it reaches apogees well in excess of 100 kilometers. So I don't think we should call it really the upper atmosphere, where like there is practically no, in this context, we can say there's practically no atmosphere to speak of. So yes, it happens at very high Mach numbers, but those speeds and Mach numbers don't carry any significance when it comes to drag or aero heating.
Right, well, I hope that answers the question. We've got another one here, which has come in from Gerard van der Haar again, and it says, how many employees have you now in New Zealand and in Delft? Now, we've covered some of that, so
yeah, I can give the answer this time a bit quicker. So in total, we're with 35 full-time employees plus a number of interns, and of those 35, slightly more than half is in the Netherlands and slightly less than half is in New Zealand, and that is constantly changing. So let's call it 50-50, and then it will always be about right.
Right, we've got a lot of congratulations coming through, and all the best to Dawn Aerospace as people are starting to leave us. Most people only have an hour on their calendars. I think we're down to the last couple of questions here, and in last four. Right, we've got one here which says, how about a UK dare? Could this work to inspire UK students?
Well, I don't see if it works in the Netherlands why it wouldn't work in the UK. So, but I believe there are a few rocketry groups in the UK as of.
There are. They tend to be independent groups of the UK Rocket Association. Yes. Yeah, we've got a competition which was talked about last week, the UK Rock, which is competition for students, but probably not quite as big as what you've been through. Right, we've got one here. David Ashford. I don't know whether you've ever spoken to David Ashford, but he was pitching to run a student challenge similar to Formula Student in the UK for competing with planes similar to your current form factor, but was unsuccessful for now. When can we see these racing one another? So, yeah.
I'm not sure if I can comment on that.
No,
we're not in the racing business at the moment, but we're always open to ideas. So,
well, of course, David Ashford is Bristol Space Planes, and so for years he's been developing the space plane on paper.
Then I guess in that case the race is already on, I guess.
Well, it is, but his is on paper and yours is flying, so there's a slight difference there. Right, we've got another question in from Luke van der Abelin, and it's, will Mark III be a true scaled up Mark II or a different design?
Well, it won't be just say enlarge everything by X% and we're done. Like there are design adaptations, obviously. in terms of thermal protection, in terms of accommodating where the second stage and payload stack will be. So it is using the same building blocks and using the same, like the core technologies that we developed and demonstrate on Mark II will be used in the Mark III, but it won't be a just scale up. There will be, of course, some redesign involved.
Okay, thank you. Right, we've got one here that says, do you have a means of transporting your space plane, a carrier aircraft perhaps? This is from Peter Robinson.
So when it is about transporting it during launch, then no, we deliberately designed this to be capable of taking off from the runway already. This, of course, means that it has to carry a bit more propellant and will be a bit bigger, but we believe that operationally speaking, this is much simpler, as we don't need to have a adapted aircraft and pilots on standby. Because even though it might look simple in the case of, for example, Virgin Orbit or the Pegasus of, well, what is now Northrop Grumman, of just sticking a rocket under an aircraft, those aircraft need a lot of redesign and not refurbishment, a lot of redesign and revision to accommodate such a heavy passenger underneath the wing or on top of the fuselage. So that's quite the project in itself. So we're not setting out to do that. Okay.
Right. Well, I think we're on our last couple of questions here. And this is again from Gerard. You still have active contact with ELDO, student rocket activities, question mark.
Well, the answer is no. The ELDO that I'm familiar with is, I believe, a precursor of the European Space Agency.
Yeah.
So as such, I don't think that society or that organization exists anymore. So we're not in contact with it. And I don't see the relation with student rocketry, unless we're referring to a different ELDO that I'm not familiar with.
No, that's the only one I know. When ELDO and ESRO got together, they became ESA.
Yeah, that's what I thought. But
that's the history I understand, but I'm a bit old for that. But anyway, right. The next one then is from Watson, and he says, payloads launched on conventional rockets must bear the stress of launch, the force and the shock. Is the Dawn launcher less stressful on payloads?
Yes. So, of course, from one rocket to another, that already differs a lot. So in general, a rocket that has a lot of solid stages and pyrotechnics on board will be much rougher in terms of vibration, acceleration, and shock than a all liquid, like, for example, the Falcon 9 that is all liquid propellant, so much smoother flight, as well as a distinct lack of pyrotechnics. In the separation mechanism there are not pyrotechnic, so that also reduces shock a lot. And we will be much more in the Falcon 9 side of the spectrum compared to, say, an all-solid rocket like Vega or PSOV. Well, PSOV is not all solid, but there are solid stages.
Okay, thank you. Yes, now Peter's come back to us when about the question that he was asking about an aircraft to carry your vehicle, and he says he was trying to ask the question of how do you transport it from your build site to some other airport worldwide?
So that depends very much where that airport is, how it will be done. We're still talking reasonably small wingspans, as this vehicle is designed for high speed. So if the distance is very far and the time allows for it, it will be shipped. And if not, it is certified as an aircraft. So it's a bit heavy on the, not so much fuel, but the oxidizer, the hydrogen peroxide consumption, but point-to-point flights are also in the realm of possibility.
Right. So you don't need a big beluga every time you want to go and launch it somewhere.
Ideally not, but that being said, if it's a not very frequent occurrence that it needs to happen, then a beluga or I don't know, Antonov 225, if it's still
Antonov.
airborne by then.
Yeah. Okay. Now this one
Actually,
here.
that might be the best one since it's already adapted to have an aircraft on top. So
Yeah.
let's hope that Antonov is still offering flights on that one if we ever need it.
Well, they only carried the Buran on the first ones. They never developed the one for HOTOL. It was just a model. So,
but I think ours is a bit smaller than HOTOL was projected to be.
Yeah.
So if there is sufficient lift and control authority to lift the Buran, then the Dawn Aerospace Mark III should be possible as well.
Okay, well, you might have the answer there. Okay, we've got one from Jack Osborne. He says, would you classify the shuttle as a space plane, seeing as it didn't actually take off from a runway?
Yeah, so it's a matter of semantics. So I'm not going to debate whether it's a space plane or not. It's definitely not an aircraft. Like, I think we can be clear about that. So it was also reusability is questionable for that vehicle, given the amount of maintenance and overhaul, a lot of overhaul it needed between flights, and practically no collision avoidance capability, very little energy left when it re-entered to divert its course if needed. Indeed, vertical takeoff with expendable boosters and expendable tanks. So it might have wings and look like an aircraft. So again, I don't want to go over the semantics. Is it a space plane or not? But it definitely is not airplane-like, and it definitely doesn't have airplane-like operations or reusability.
Okay. Right, we've got this one is from Gerard again, and he says, sorry, I meant DARE and Stratos activities.
In that sense, yes. So many of the people working at our company were part of DARE before. And half our company is located in Delft, or formerly Delft, which is a little village next to it, but we're very close to the university and hence the DARE group. So yeah, we still meet these people. A number of our interns are still members there. So we're in contact and help each other out where needed.
Okay, now I think we're going to probably have to close up soon. I've got another meeting starting in about 3/4 of an hour's time. I've got one here from Howard Melvin Hacker, who says, does Dawn have navigation lights and strobes for nighttime launches?
It has navigation lights for sure, as that was a even the Mark I already had navigation lights, as that was a requirement to operate under the Part 101 certification or rule set in New Zealand. Rule set, I should say, for that one. Strobe lights, I would have to double check with my colleague. We don't particularly design it for nighttime launches, but I'm sure it can be accommodated. I would have to check with my colleague, to be honest. I know it has navigation lights. The strobe, I don't know.
Okay. I think this is the last question here. Let's see. We've got from Jack Osborne again. Do you have any ambitions to make a space plane capable of manned flight, or are you strictly UAV?
I would say for the foreseeable future, strictly UAV. Having the ambition, yeah, definitely. But at what time scale? I really cannot comment, and it's not foreseen at this moment that we will go into manned flight anytime soon.
Okay, right. I think there's one more question here. Oh, it's Supernova Labs. He's got Aerospike ?
Yes. Potentially, but right now, no. Especially on the small scale that the Mark II is. We were first planning an Aerospace, but when working through the math and the physics, it didn't work out in its favor. So we have a much more traditional design there. At the much larger scale for the Mark III, that assessment will be made again. I don't expect the outcome to change, but who knows?
Okay, right. Well, I think we're going to have to close up now. So no more questions, I'm afraid. We seem to have got through the lot and seem to be a lot more than the first 20. Oh, we've answered 52. So congratulations. That's the highest we've ever had.
Oh, it's a high score.
It is. So we'll have
will be a competition next or whenever it is with the orbit.
Well, that's going to be, in fact, I was going to say that's going to be on the 25th of November. And Chris Brunskill is going to be telling us all about the deorbit. And I always thought deorbit meant they only brought things down, but it sounds as if they launched bits of kit like yours.
Well, I don't want to steal his thunder, so I won't go into too much detail what they do. But I believe, like nowadays, it's very much bringing stuff up.
Yes, I think that's what they're concentrating on because that's where the money is. So people haven't got wise to the fact that bringing stuff down is going to cost an absolute fortune. Anyway,
when it carries our kit, as you called it, the green propulsion technology, you can bring it down in a very affordable manner.
Oh, yes.
That's actually key. Like all joking aside, the propulsion is not only to reach your desired orbit in time, but it's to ensure collision avoidance capability for satellites, which I believe is already very important, but it's important. It's growing very fast with the amount of debris and the amount of active satellites booming as we speak. And of course, it also being liquid propulsion, so being restartable great many times. It's ideal for a deorbit maneuver as well at the end of life.
Yeah. Oh, well, that's great.
That's in fact what our customers use it for, getting to the right orbit, staying at the right orbit, and getting out of the way again when the job is done.
Well, it sounds as if you're going to have some interesting questions to ask Chris next time. So that 25th, I hope everyone puts that in their diaries.
I just did. So
quite a discussion going on. And we'll see you all on the 25th of November for the next one. And really must thank you very much for spending so much time with us. I know you're busy, but it's been a fascinating open door discussion. And I think we've covered an awful lot of ground tonight. So thank you very much indeed. And thanks to everyone else that was watching and listening, because they put some pretty tough questions to you.
Yeah, well, it was my pleasure being here. Thank you a lot for hosting us, for making this possible, and also thank you to indeed all the should you call them listeners, people who tuned in, listening in, as well as all the very sometimes tough but lively questions. I think it was a very engaging session today.
Yep, and they all liked your video or the recording you made, because that has been seen by many people now.
Very good then.
Okay, well, thank you very much, and good night from here, and good night or good day to everyone else. Thank you very much. Bye-bye.
Thank you so much. Bye-bye.
Bye.